Good morning, good day, good evening, good night. Hello and welcome, fellow coders. As you progress through my tutorial series, I guess you've already noticed that the further you get, the more concepts are kind of interacting with one another. And today's video is no exception to that. It will be the next step to the slicers and maps videos, so definitely make sure to check them out, because today we're going to iterate over these data structures. So without further ado, let's get coding. Loops are used to execute a specific block of code multiple times, or more precisely, a specified amount of times. The example I'm using is super simple. We will sum up the numbers from 1 to 9 and print out the result. For that, let's first declare a sum variable and initialize it with the value of 0. Now for the fun part. In all programming languages I know there are many different kind of loops. In Go, compared to many other languages, loops are super simple, because you basically need to remember only one single keyword. The for keyword. The so-called for loop, as the name suggests, starts with the for keyword and consists of 3 parts. First, the initialization, second, a condition, and third, a post statement, followed by curly brackets that define a code block that will contain the code that gets executed every single run of the loop. The correct technical term for that is iteration. So an iteration is the execution of the code block of a loop. All of these parts are separated by semicolons, which I already wrote down from muscle memory. Okay, now let's go over all these parts individually. The first part, the initialization, initializes a variable that can be used within the code block of the for loop. Typically, this variable is named I for iteration. Since I want to sum up all numbers beginning from 1, I am going to initialize I with the value 1. This first part only gets executed once for each for loop, so I is set to 1 only once before the code block gets executed for the first time. That is not the case for the second part, the condition. The condition is a boolean expression that gets evaluated every single iteration. This is the part when, or rather under what condition, your for loop will end. Since it will get checked every single iteration, it has to be true every time you want your code block to get executed. As soon as the condition results in false, the loop will stop iterating. In our example, that is the case as soon as I is greater than 9. So as long as I is smaller than 10, the code block will get executed. Now for the last part, the post statement. The post statement, as the name suggests, will get executed after every single iteration, and is typically used to increase the initialized variable I. Here I'm simply increasing I by 1 at the end of every single iteration. So now let's get into the code block. Since I want to sum up all the values from 1 to 9, I can simply add the value of I to the sum at each iteration. To give you a better understanding of what's actually happening inside the loop, let me go ahead and print out the value I as well as the current sum at the point of I. At the end of the for loop, I will simply be printing out the final result of the sum. Now let's go ahead and run the code and see what's actually happening. Each line of the output gives us the current iteration as well as the sum. Starting with the first iteration, or I equal to 1, the sum is also 1. Next, I gets incremented by 1, exactly how it's supposed to, and the current value of I is added to the value of sum, resulting in a sum of 3. This happens all the way until I has the value of 10. What happens then is that the condition results to false and the for loop stops iterating. And now everything after the for loop gets executed. In our case, that's the final print statement. All code that is written after the for loop only gets executed after the loop has finished. Make sure to remember this. There is one final thing I would like to mention about for loops. The variable I is only available inside the loop, so if you try to access the value of I after the closing bracket, the compiler tells you that it does not know I. Alright, now for loops are kind of the bread and butter when it comes to loops in programming, but there are other loops that are sometimes a better fit, for instance the while loop. Compared to the for loop, the while loop has only one part, the condition. So let's get rid of the initialization and the post statement. The while loop iterates as long as the condition results in true and stops as soon as it results in false. But since we do not have the variable I anymore, we now need to work with the sum in order to stop the loop. To do that, let's replace I with sum. So the loop will run as long as sum is smaller than 10, or in other words, stop as soon as sum exceeds the value of 9. Inside the code block, since the iteration variable I does not exist anymore, I will simply add sum to the last value of sum, and of course remove I from the print statement. Now I want you to have a look at the current loop, and guess what will happen if I run the code. Pause the video if necessary and go over each iteration in your head. Do you have an idea? Great. Now let's go in and run the code and see what actually happens. Nice, we successfully created an infinite loop. Did you guess that right? If so, congratulations. The problem is that the condition that will stop the loop is never met. Since sum is initialized with 0, each and every iteration will simply add 0 to the current value of sum, which is 0 as well. That's why the output is always the same and stating that sum is 0. Infinite loops, if coded and executed, need to be terminated by hand. You can do that by hitting Ctrl+C on the keyboard while the code is running in the terminal. You can see in the output that the terminal received a specific signal and interrupted the execution. Again, I would like to encourage you to try to figure out in your head what happens if I initialize sum with a value of 1. Got an idea? Okay. Then let's go ahead and run the code. It prints out the values 2, 4, 8 and 16. And then 16 again as the final result of the sum. Was that your guess? If so, congratulations. So what did we do? We went from for loops to while loops by omitting the initialization and the post statement. The next step would be to get rid of the condition as well, right? This is called an infinite loop. Since we do not have a condition which will tell the loop to stop, it will run indefinitely. This time though, we will write it on purpose. You can see that the code editor is underlying the last print statement, telling me that this code is unreachable, which is true since the loop will run forever. But there is one way to prevent that. Instead of defining the condition that will stop the loop from executing any further, we will define the condition inside the loop. Again, let's stop iterating as soon as the sum is greater than 10. To accomplish that, we can make use of the break keyword. Break now tells the loop that it should stop executing. It is always used after some kind of condition, like we have right here. Now let's go ahead and run our code to see the output. Same as before, as soon as the sum is greater than 10, which is the case when we add a to the previous value of sum, this condition evaluates to true, the break statement gets executed and the loop stops iterating. There is one more keyword that you can kind of use to manipulate the execution of loops, and that is the continue keyword. Before I give you an example, let me quickly change that so that the sum always gets incremented by 1. This loop will start with the sum equal to 1, increment it by 1, print out its value and check if the sum is greater than 10. As soon as that's the case, which is at the value of 11, the loop will stop executing. Now let's say for instance we would like to skip the execution of the loop for values that are smaller than 5. We can do that by first checking if the value of sum is smaller than 5, and if that's the case, stop this iteration of the loop by using the continue keyword. In contrast to break, which stops the loop altogether, continue only stops one iteration, but the loop will still continue to run. Now what this code does is, it will increment the sum by 1 every single iteration, then check if the sum is smaller than 5. If that's the case, stop this iteration. If the sum is equal or greater to 5, it will continue with the print statement. And as soon as the sum is greater than 10, stop the loop and print out the final result. Let's run the code and check if that's actually the case. Fantastic. Continues and breaks are used all the time in writing loops, so definitely make sure to understand their difference. Okay, that is it for loops so far, but I promised you to show you how you can use loops to iterate over slices and maps. To do that, let me quickly create a simple integer slice containing the values from 1 to 9. Using the for loop, we can now initialize the iteration variable I with the value of 0, since we want to start iterating from the first element. The loop should stop iterating as soon as we have retrieved the last element of the slice, so the condition has to be I smaller than the length of ints. Lastly, I needs to be incremented by 1 after every single iteration. As for the code block, I will simply print out the index as well as the value of the slice at the given index. This way you can see that this loop will iterate over every single element. Running the code shows us exactly what we expected, the value of the element of ints at their specific index within the slice. For loops are often used to iterate over slices, but how about maps? Let's try that. Before I define the map, I will just comment out these lines because I will need them in a moment. Now, as for the map, I'm going to name it ints as well, so I don't have to change anything within the loop. As for the keys and values of the map, I will be defining 3 integer values as keys and their respective strings as values. Before I run the code, again, I would like to give you the chance to try to figure out what the output will be, and pause the video if necessary. Got it? Cool. Now, running the code shows us something unfortunate. Since the loop iterates from 0 up until it hits the length of the map, which is 3 by the way, it retrieves the values 0, 1 and 2. So as you can see in the output, the map returns an empty string for the keys 0 and 2, whereas the value for the key 1 actually gets printed out. But only because the number 1 is one of the values I has while iterating. If you don't understand how this exactly works, definitely make sure to check out my tutorials on maps. This will make it a whole lot clearer. But what I'm trying to show you here is that for loops do not really help us when iterating over maps, so we need something else. And that is where the range keyword comes into play. Range is used whenever you want to iterate over all elements of, for instance, a map, a slice or an array. It replaces all these 3 statements and has the following syntax. Following the range keyword is the data structure you want to iterate over. In this case, that is the ints map. Range provides us with 2 values for every single iteration. Depending on what you're iterating over, range will return different kinds of values. I will show you that in a minute. For now, since we are iterating over a map, these 2 values are the key and the value during each and every single iteration. If you go ahead and run the code, you can see that this time every single key and its corresponding value gets printed out. Cool, huh? But the best thing now is that we can simply replace the map with the slice, and range will still give us 2 values for every single iteration. For slices, the first value is the index and the second is the value, so let's rename k to I so it's easier to comprehend. As you can see when running the code, we do not need to change anything. The loop using the range keyword still gives us every single element within a slice. Awesome, right? Now one cool thing is that if for instance you do not need the index within the loop, you can simply go ahead and omit it. This way you will only have access to the value of each element during the iteration. You can go ahead and remove one value that range returns, but you have to be careful. This will only return the index when iterating over slices and arrays. As for maps, to no surprise, this will be the key. See? So I would suggest always defining both values that range returns and omitting the one you do not need. That makes the code more explicit and therefore introduces less bugs. And that is it for today, guys. If you enjoyed watching this one, like the channel and subscribe to the video. No. And until next time, keep on coding.